Hello, this is an example that applies some important terms that you've seen in Chapter 1 and 2, specifically terms like sample, population, statistic, parameter, inferential statistics, descriptive statistics. So here we have an application of those terms in kind of a real-world example. What I've got here is a passage that I want to fill in the blanks using the appropriate terms. So Robert here is interested in the average length of all white perch in Lake Nacogdoches. So Robert's an avid fisherman, say, and he's interested in this average length. Well, so he wants to estimate this quantity. To do so, he obtains 120 white perch from the lake and finds their mean length. So say he either fishes with a rod and reel until he catches 120 white perch, or he has a net or some other device of catching these perch. Now, the 120 white perch constitute a sample. If you recall, the sample is the subset of a population. The population is the larger group of interest. Here, the larger group of interest is all white perch, and the 120 is just a subset of that entire group. Now, the mean length of this sample is an example of a statistic. If you recall that a statistic is a numerical characteristic of a sample. So the average length of these 120 describes that sample there. Another possible statistic you could have would be the proportion of white perch in this 120 that are males, or the proportion of white perch in this 120 that are less than 10 inches, or something like that. Okay, well, all white perch in Lake Nacogdoches is the population. That's the group. We're talking about all white perch. We're talking about the population. Okay? So while the mean of all white perch in Lake Nacogdoches is an example of a parameter, the parameter, the mean of all white perch, that's the parameter. Parameter describes as a numerical characteristic of the population. Okay? Another parameter of this population might be the proportion of all white perch in the lake that are males, or again, the proportion of all white perch in the lake that are less than 10 inches long. Okay, so if you think about these four terms, there's an analogy that can be drawn, right? A sample is to a population as a statistic is to a parameter. Okay, or maybe I said that wrong. A statistic is is to a sample as a parameter is to a population. Okay, lastly here, using the 120 white perch to draw conclusions about all white perch in the lake is an example of statistical inference. Statistical inference. The idea of inference is to draw conclusions based on partial information. Now you could have in this blank statistical inference or inferential statistics. In the statistics field, those are synonymous terms or ideas. Now, so we're doing inference when we take the sample, the 120 white perch, to draw conclusions about the population. Okay? And in general, when you use the sample information to make conclusions about the population or to draw inferences about the population, you are doing statistical inference. Now, inference is a big idea in statistics, and that is pretty much the ultimate goal for this class. And when we get to the end of the class, or really even before the end of the class, we'll be doing actual statistical inference. We could do this sort of thing that's being described here in words. We could actually come up with data analysis means that allow us to do this, what's described here in the last sentence. Okay, so that's an example. A second example that I want to give to you deals with a car example here. So what we've got here is the mean or average gas mileage, miles per gallon, of all new VW bugs is to be estimated by determining the mean miles per gallon from a random sample of 36 new VW bugs. Okay, so a few questions here I want to ask about this. So the 36 bugs will be considered a sample, right? That is, well, it's pretty straightforward here. It says that the random sample of 36 bugs, that would be the sample. That's the portion of the larger group that we're looking at. The larger group is given in the second question here. All VW bugs would be considered the population. Okay, hopefully not too hard. Now the process of using the information from the 36 VW bugs to draw conclusions about all bugs is known as, well, inferential statistics. Inferential statistics, okay. Moving on here to the next page. The measurement, miles per gallon, would be considered a, well, so it's not a silly measurement. I hope you wouldn't pick that. It's actually a quantitative measurement, right? It can, when this is a chapter 2 idea, quantitative measurement, it can be numerically described. Miles per gallon can, and so it's a quantitative measurement. Now, if you ask each of the 36 owners of the VW bugs in the sample if they purchased the extended warranty that was available, the response would be yes or no. This kind of response is actually a qualitative measurement. There's really no numerical response to asking that question. Although you could make it a 0-1 response, that would still be a qualitative measurement and not a quantitative measurement. Okay, the mean miles per gallon for all bugs will be considered D, the parameter. So again, the parameter is the term that describes, or not the term, but it's the numerical characteristic that describes the population. All VW bugs is the population. The mean miles per gallon for all these cars describes it. It gives us some sense of how well, what the fuel efficiency is for this particular type of car. Okay. All right. The mean mile per gallon for the 36 bugs would be considered a statistic. Okay. Again, here we've got a numerical characteristic that's describing the sample, and the numerical characteristic that describes the sample is a statistic. Okay. Well, I hope going through these quick exercises were useful for you in understanding these important terms. It is very important that you have a good understanding, a good basis for these foundational terms in statistics.